There are many examples of applications of hyperbolas. You can see them in architecture, you can see them in engineering, but one of the examples we're going to look at today is the idea of navigation systems and how they might be used. If you remember correctly, by definition in a hyperbola, this distance between, for this point, if we do d1 minus d2 and take that magnitude, we should get a constant. Imagine that this is a ship traveling along the path of a hyperbola. If they receive a communication signal from towers that are located at the foci of the hyperbola, as long as they keep a constant time that it takes to receive those symbols, they'll know that those signals, they'll know that they're keeping their distance traveling along the arc of that hyperbola. So for example, imagine that a ship measures the time difference between receiving the first signal and the second signal to be a time difference of 0.000108 seconds. Remember the idea that the signal, we're going to assume it's moving at the speed of light, which is 186,000 miles per second. As long as they are staying on the path of this hyperbola, that time difference should stay the same. If this ship is traveling and wants to know where it's going to reach shore, remember that this distance minus this distance is going to leave you with this value, which is 2a. And so from wherever the center of that hyperbola is, they can calculate their distance here. Well, we know a formula for distance. Distance is rate times time. We know the rate at which the sounds are traveling, or the signal is traveling, times the time difference. And that's going to give us a distance of 20 miles. Now remember, that distance of 20 miles is that constant difference. Because that distance of 20 miles equals 2a, then we can divide both sides by 2, and we know that a, the distance from the center of the hyperbola to one of the vertices, is 10 miles. So they will arrive 10 miles from whatever coordinate this is when they reach shore, assuming they're traveling along the path of that parabola. Hyperbola, sorry.